monitoring Teams voice and video collaboration with Netscout in Ngeniusone. This series has focused on a number of topics, from how mission-critical unified collaboration platforms are, problems affecting voice and video quality, and how Netscout's smart data, when strategically deployed in the infrastructure with Ngeniusone, can quickly get to the root cause of voice and video quality issues. This time I'll focus on Teams, Microsoft's next evolution of collaboration tools, hosted in the cloud, next generation Office 365 and Skype for Business, as it were. Although Teams is hosted in Azure Cloud, your users are everywhere and they want to collaborate, and it's up to you to make sure that they get the best user experience they can. Call routing for these voice and video conferencing calls can be quite diverse, depending on your enterprise environment. Your data center may well include colos or express route links to Azure Teams, and of course your users may be at home, in the branch, HQ, contact centers, or a mix of all of this. Teams media, voice and video quality can be monitored with smart data in the data center, HQ branch, contact center, colo, and because it supports the Teams voice and video protocols, SRTP, and the codecs in use such as Opus, G722, H.264, Ngeniusone can really troubleshoot quality issues, if there are any, within your environment. The way Teams callings works is that when a user calls another, behind the scenes, the signaling as it were, the client figures out the best route across the network for the voice and video to travel. It calls out to Azure Teams servers over the network, the internet through the VPN via express route to establish whether direct connectivity to the callee is possible or a Teams media relay server is necessary. A set of candidate ports and IP addresses, including local relay and reflexive public addresses, is exchanged between the parties, and the STUN protocol connectivity messages establish the best candidate. So if direct media, SRTP, peer-to-peer connectivity is not possible, say one user is inside the customer network and the other outside, such as a mobile cloud user, then the Teams transport relay candidate is chosen between the two, and SRTP or MS multiplex turn is used for the media. All this complexity designed to get the best connectivity and therefore quality for the call. Depending on your environment, the media still traverses your domain, e.g. branch, HQ, contact center, WAN, SD-WAN, data center, colo, or express route, and monitoring at multiple locations along the call path provides more information to pinpoint the source of the problem and establish Teams traffic volumes throughout your network. An example: an HQ user makes a video call to a home worker. Teams' chosen candidate path is via the data center, then the colo, then via express route to the home worker via a Microsoft Relay server. With instrumentation in place along that call path, we see how the video quality of the call performs as it traverses your network. This is how Ngeniusone Media Monitor shows the quality across these domains. In this case, the call from HQ goes out to the Teams via the data center, colo, and then through express route to Azure. You can see the call quality in both directions, and you see great quality going towards Teams, but coming back from Teams, as soon as it hits your network, it's already bad. Ngeniusone also presents the QoS settings for the call, all set to best effort 0, both directions across the network and into your network. Again, an indicator that traffic prioritization is not taking place, perhaps a configuration problem throughout the service chain, and a possible cause for the Teams quality issues. So a far-end problem out of your domain, but your users will still not be happy. You can use this as the evidence you need to establish consistent problems in the Teams experience, home worker Teams call problems, HQ problems, data center or colo issues, or consistent problems coming from Azure via express route, as in this case. Likewise, take another example, a branch user communicating with HQ. You see here the call is directly connected, branch to HQ, but the quality, as it leaves the branch and enters the HQ, it's degraded due to the WAN or SD-WAN. A profile which tells you a different story, a problem in your domain, and something for you to target. By correlating the time of the call or bad calls with what was going on with the SD-WAN means that you'll get a handle of what was going on to assist in solving that Teams voice or video quality issues too. So to sum up, yes, Teams is in the cloud, but your users are everywhere, and their calls between each other probably cross a point in your infrastructure which can be monitored with smart data and Ngeniusone. If Teams call routing goes through a colo via express route, you can catch the service quality and volume of calls at that point. If it's a branch point-to-point HQ to branch call, you can be instrumented either side. Even a call from a customer to a home worker. The home worker call may be routed through your domain by virtue of your VPN routing policies in your organization, with the result that the call goes through your domain, your data center, and then out through ExpressRoute, instrumented in this example at the colo. All key points of instrumentation for Netscout Smart Data, and any or all of these will help you diagnose your team's collaboration, voice and video quality with Ngeniusone.